So we're running a little bit later here than I would plan to, because I want to at least at most get you back to labs by 3. So we'll spend a little bit more time here kind of fleshing this example out, and then we'll finish up tomorrow, because I don't want to spend too much more here. I want to make sure you guys have time to actually work on the labs. Cool?
Sweet. All right.
So we're talking about basically how to build this class, and we left off by creating a basic class here with some fields, and we've got a constructor. Okay, so let's go ahead and start to try and use that class as written. Right. So I'm going to pull up main here. I'm actually going to put these, drag this so I can have these side by side, so we can look at these at the same time. So let's say, probably the first place to start is I want to create a new person. So let's say person P is the name of my variable, and we're going to say is equal to new person. Right? Okay. So now I need to pass in some parameters to that constructor, because if we see, it needs all of those things. If I look at what's happening here, it says, hey, I can't do this, right? There's no constructor that takes 0 parameters, is effectively what it's telling me. So I can't do this because I haven't given it values. Right, so I need to give it some values. So maybe I say Paul Smith, and my age is, gosh, I should know these things. Math. 34. Height, let's say 5.5. And single false. Right? So we can construct an object that way. Now, what is it complaining about here? I think I know what it is. So look at, can everybody see the error that's popping up?
Yeah.
It says person, this cannot be applied to A. So the first thing it says is the parameters that I am passing. The second thing is the parameters that it's expecting. So here it says I'm passing string short. Actually, it should be right. It's actually expecting string short double boolean, right? But I'm passing it string int double boolean. Did you hear the problem in there?
Int versus short.
Right. So the problem is that this is expected as a short, right? So how can I force it to be a short?
You cast it,
I could cast it.
or you parse it like short the value of, or you can add decimal.
Yeah, I'm thinking, does it have a suffix? No, yeah. So casting.
Oh no, it does. It does. It has an L. It's an L.
Well, L is for long.
Really? I thought you could use it for short too.
No.
I thought that was a suffix.
When you do a suffix, the suffix says what kind it is. So, for instance, L says long, F says float, D is double. There's no suffix that gives it more than one data type.
Oh, so you have to. Oh yeah, you have to.
So in this case, you do have to cast it as short. Hint, hint. That's why sometimes we just go ahead and make things ints, because sometimes it's much more trouble than it's worth to try and do a bunch of casting, right? So in this case, if I want to have it as a short, I end up needing to cast that value. Okay. So I created a person object, right? And let's say, what are some things I might want to do with this? So I might say system.out.println, and maybe you wouldn't want to print the person's name, right? How would I get the person's name? What would I put in?
P.name.
P.name. Okay. So let's try that. Something's in red. Well, why is that? It's saying I can't do that. Name has private access, right? So because it's private, I can't access it, right? So if I want to be able to print it out here, what do I need to do? Because right now I can't print out the name.
Change it to public right where you got it highlighted.
Okay, so let's change it to public. And now we should be able to try it. Right?
Really? I thought you can make those private as long as you can access it through the instantiation. Well, that's weird.
Remember, private means that you cannot access it in any other class. I can access it here, even though it's private, because it's in the same class. Does that follow? The constructor is still part of that class.
Yep.
So I can construct the person. So one way to do that would be to make it public. Also worth noting in there, what happens if I leave off the access modifier? If I leave off the access modifier, do you see that it's working, right? Do you see that?
Yeah, it's package, right?
It's package level. So, it's definitely not private. You see that? Because I'm definitely accessing it right here. Okay. So those are two different things. And at this point, I'll cover that tomorrow because we won't have time for me to get into that. But just, what you should see right there is that private and package are not the same. So really, realistically speaking, I'd rather not make my fields public. Okay, typically that's considered bad practice in Java. So what should I do instead? I want to leave this as private. What could I do instead?
You should create an accessor.
I could create an accessor. Yep. So an accessor, remember, is specifically any method that can read values. And in this case, we're going to call it a getter, simply because the only thing it's going to do is return the value of a field. So I'm going to say get name, and that is going to return the name. That's my getter. Okay, so now I can call over here, rather than accessing the name field, I can access that name getter. Cool? Any questions?
Nope.
So what if I want to now set the value? Can I just do p.name is equal to test? I can't.
You gotta make a setter.
I gotta make a
set
setter.
name method.
Right. So to access these values, I'm going to need to make setters and getters. So public. Remember, setters are typically void because they don't need to take a value. So I'm going to say set name and then string value. So the value it's going to be set to. And so I could say name is equal to value, right? So I can use the setter to change the value. Now, the mistake that a lot of people make is that then they go over here and they say, well, it's not p.name is equal to test. A lot of people then try to go p.setName is equal to test. Right? But that doesn't work. Why doesn't that work?
It's not a variable it's assigned to.
Right. I'm treating setName as a field. Right? I can't assign that way. So if I want to call my setter, what do I have to write?
P.set name, parentheses, the name, the value,
Right.
whatever it is.
Yeah, so I have to call it as a method because, well, it is a method, right? So if I do that now, there we go. So we can see test on the console. So I can write my getters and I can write my setters that way. Does that make sense? So I've got my getters and my setters.
Yep.
So typically we're going to use those words specifically: get name, set name. The one that's weird with Java is the convention for booleans is a little bit different. So for booleans, we typically don't use the word get. So I could very well write this as get is single because that's the name of my variable here. Return is single. But that's kind of clunky. Can you see that name is kind of clunky?
Yeah.
So typically what we'll do, we use a different verb here. Any guesses as to what that verb might be? It's typically one of two things. You know, I could
Put.
put would be saying I'm changing a value. I could say get single or get is single. Usually what I do is single. Does that make sense? Usually the two acronyms you use for booleans are either is or has. Right? So that's usually the particular verb that you'll see there. Is or has if it's a boolean. Usually it's not get.
So it would be public void as single, and then
Well, here I'm going to call it is single. Which is interesting because these now have the same thing, right? So I may have to clarify, for instance, what is it, because now the method has the same name.
what about the setter? How would that be?
That one's usually pretty self-explanatory. Let me run this real quick and see just that works. So it does come up as false.
See, Mr. Smith, this is why I was confused because I was like sitting there thinking, I'm like, wait, how come you can't get the name? But I forgot you haven't made a getter yet. So I was like, oh, there it goes.
Mm-hmm. Yeah. So if I want to say public void, well, I'm probably still going to use the word set for booleans. And then you might say set is single. Some people would also name this as set single. Sometimes we keep that. Sometimes I'll keep the verb in there, and sometimes I don't. Some people do and don't. So this would be Boolean value. So the one we get weird about is usually just if it's a Boolean, then we use something other than get. Cool?
Yeah, I got a question there up above, and we were setting the. Oh, never mind. I got my answer. Okay. All right.
Yeah. So that's kind of the basic setup for creating a class. Oftentimes, another thing that you frequently find yourself wanting to do is maybe you just want to log the object itself, right? So here I'm going to say systemout.println p, right? And if I run that, look at what I get. Everybody see that in the output? So what you have at the beginning here is you've got the package name, you've got the class name, and then any guess as to what that is after there? You've seen this already.
Spot in memory.
It's the place in memory. It's the reference, right? So it's telling me the name of the class and where it's in memory. That's usually not very helpful, right? Usually not very helpful. Any guesses as to what I need to do to make that provide something more useful? Spit out something more useful?
Two-string.
Probably two-string. So what do you mean by two-string? Two-string is part of that answer. What do I need to do? What do we call it?
Overloaded?
Close. Overload is when you have multiple versions with the same signature. Override, right? So there's every object has a basic two-string method. I need to override that. So typically with modern Java, the way you're gonna start that out, you're gonna start with this annotation. Starts with an @ sign. You say @ override, and then we're gonna override the two-string method. So it'll put a basic implementation of it down here. So you can see it starts with @override. It's a public method, returns a string. It's called toString. So implicitly in here, it's calling that toString method. So we just need to change that to return what we want it to return, right? So just to test it, let's say just return person, okay? So you can see how this has changed, right? So it is calling that method, right? So what might be more helpful then is to start, putting some of the values in there that are set. So anybody that's done some research already, how can I, maybe if I want to put the name in here, how can I put that in there? What are my options?
Can you repeat that again?
So let's say I want to put together a string here. It's going to be like person, parentheses, and all the values in here. What are my options to kind of get the actual name in there?
You can just grab it from the get name. So basically concatenate it. So you put two quotes right there.
Okay.
And then two plus signs.
Mm-hmm.
And then you put get name.
Or I could just do name, right?
Yeah, or name. Yeah, because it's private. It's in class.
I could put name directly here because I don't need to go through the getter. Right, so that would start as person test, and let me comment this out so I'm back at the original data. So I could do that, right? But this can quickly, if I'm going to put all these values in here, that's going to get very cumbersome really quickly, right? So I start putting that in, and then I'll say, well, I want commas in between.
Oh, can you do the same thing as like with the tildes and then put the dollar sign or no?
So that's a very good question. The unfortunate answer is not exactly. So template strings, as far as I know, are not a thing yet in Java. They don't have a template string format. What they do have is something a little bit older, just to be fair, and it has a little bit of a less obvious syntax, but it's one that you want to learn for working with Java, and it'll apply when we get into the world of Android. So in Java, there's a method called string.format. Okay, string.format is the name of that method, and what I give it is the first argument is a very special string. The remaining arguments are things to kind of put into that string. So in that first string, I'll specify some holes where I'm going to drop some data. Everybody with me there?
Yeah.
Specify some holes where I'm going to drop some data. We call those placeholders. So I need to say I want some data here, and then later I say what data am I going to put there. Now the syntax that's used, I will pardon me if this is a little bit strange. The reason that it exists and the reason the way that it's here actually ties back to the C language. So back in the world of C, there was a format method that used this same sort of similar syntax to this. Since then, both C# and JavaScript have gone a different route. So they don't use the same syntax. if you ever do Python coding, this does exist in Python. It's a very similar syntax in Python. But this, remember, is rooted in C. Okay, so pardon the cryptic nature of things. If you want to put a placeholder, it starts with a %. Okay, so it always starts with a %. The next thing that you put in there is the data type of the thing you're going to put there. So any guesses as to what data type S represents?
String.
Represents string. Okay. So I'm going to put a string here, which is going to be the name. The next thing I want to put is the age. Okay, so the age is a short, right? The age is a short. Okay. This is the one you need to write down and remember. %D. Okay. %D is anytime you need to represent, and this is this is weird. %D is an integer. %D is how you output an integer. It stands for decimal, but it doesn't really mean that, or digit. It means integer. So any data type that is an integer, whether it be a long, if it's a long, or it's a integer, it's a short, or a byte, all of those would be %D. Okay? It's not floating point. If you need a floating point number, it's another letter. Everybody with me? So S is string, D is integer, %F, that is floating point. So that would include floats and doubles. Okay? Everybody following?
Yep. I thought, but Mr. Smith, can't you also use the dot replace method?
No. Dot replace doesn't work here. That's something else.
Okay.
Dot replace does not work here. This is definitely something you don't want to do dot replace for. Okay. So %S, %D, %F, and then the last one would be a Boolean. And I actually don't know that I've ever needed to format a Boolean. So let me check that one real quick. So string, so Java, actually I was right here on the string class. Java string format. Or maybe I'll just go back to the string class. I'll go back here. Oh, I saw it right there. So string. So when you're looking up the API docs, you can go generally down to the method and find out how it works. So we're going to go down here. Now, unfortunately, most of the Java documentation is pretty good, but you look at this and you go like, well, where's the explanation of what the format string needs to be, right? Now, notice in the parameters, everybody see this? It says a format string. There's a nice helpful link here. Okay, so I'm going to follow that, and that's going to bring me over to a completely another page, which it will kind of specify in depth what the format syntax is. And I don't think that there is one. I think maybe there isn't one for Booleans. Nope, there's not. As I like, I've never used one for Booleans, but maybe that's not. Oh wait, if the argument is null, the variable is false. Oh yeah, so it is B. B is the one I want. So %B. So when we're spitting things out there, so remember %S string, %D is integer, %F is floating point, %B is Boolean. So then I'm going to, as the further arguments in here to string.format, I'll specify the values I want to put there. So name I want to go into the first slot, age I want to go in the next slot, height's going to go in the slot after that, and then finally is single. Right? So that's how you use the string formatting stuff. Do you see that?
Yep.
Now, one thing you should immediately ask Notice how many decimal places that I'm getting here for the float. I probably want to specify how many decimal places I want. Now, I don't want to get into the full syntax for how you format numbers, but that's one that's really helpful to know. The way that you specify how many digits you want is between the $sign and the character class, which in this case is F. You can put a bunch of other qualifiers to say how to format it. So in this case, the what I want to put in there is dot, and then the number of decimal places I want after the dot. How many decimal places do I want after the dot? What would be a good number for height?
1.
Okay, so let's say 1. So if I say dot 1, it'll round it to 1 decimal place. If I say dot 2, it'd be to 2 decimal places, etc. Does that follow?
Wouldn't you want to do 2 though on something like that, since somebody's height can be like 5'10", 5'11", 5'12", or not 5'12"? I mean, like 5'11".
It's true, but if let's say I'm representing this in, there's another question, right? Is this height in inches or is it in feet? Because you're assuming it's in feet, right? And
Yeah.
so if this is 5.5 feet, that's 5 feet in how many inches?
Yeah, that'd be 6 inches.
6 inches, right? It's 5 feet 6 inches. So does adding 2 decimal places really make a lot of sense?
No.
Not really, because of
Not like it's going to be that much thought into it at the end of it. They're kind of just going to be like, oh, okay, cool.
Yeah, but if that was in inches, that's a different story, right? So if I say this is 5.5 inches, right, that might be a different deal. So I would have to do some more complicated formatting if I wanted to actually represent that as, say, 5 feet 6 inches. I'd have to put a little bit more logic in there, because that's not something you get out of the box, unfortunately. Okay. Does that help? Kind of seeing some of the formatting stuff? Might factor into some of your labs. And again, you will see this when we get into the Java world, because there are some places where we use formatting like this. In the Android world, that does apply and that does get used. So it's worth knowing a little bit about that formatting syntax.
Yeah, so order definitely does matter there.
Mm-hmm. Yeah, the order definitely matters.
But if, let's say, like name and age were both strings, then you could just swap those out, because it would just be %s on the other side.
Swap those out. So
see how that's S and D. Let's say name and age were both strings.
So let's say integer or short dot toString. Okay. So now age is a string. So if it's a string, and I tell it to format it this way, you're going to see it's going to give me an error, because say, well, D doesn't work because it's a string.
Okay, so just make %D %s, and that's
well. So in this case, it would need to be %s.
Yeah, right, exactly. Okay, all right.
So the type, the letter that you put there has to correspond to the data type of the variable that you're putting in there into that slot.
What's the name of the % there? Like, what's the terminology?
Well, so we call that combination %D is a placeholder. %1 is a placeholder.
Okay, it's a little different than C#. I remember something with 0 and 1 and 2.
C# has a different format.
Okay.
C# took a different format. But this is a leftover from, actually I think it's leftover from printf in C, is basically what it's following after. Anyway, so that's kind of your basics of getting started. One of the common methods you'll also want to implement anytime you create a class like this, oftentimes you want to compare two objects and see if they're equal, right? So let's say I make another person here, and we'll call this Q. How do I compare those two objects to see if they're the same? Do I say P equals Q?
P dot equals parentheses Q.
Okay, right. Because look at what I get here, right? They're two different places in memory, so false. Let's say I do P dot equals Q. What do I get now? I still get false.
It's because a person's not a string. It's like it's a whole class.
Not really. Not really. String has the equals method implemented specifically for it. The catch is the object, right? Object class, object's the parent of anything I create here. So parent is a subclass of object. Object already defines the equals method, but its default implementation does something, right? So you saw what the toString did out of the box. Do you see that? It was the class and the reference. So out of the box, what equals does is it compares the memory addresses. The equals that you get without implementing one just does this. P equals Q. Just does the same thing.
Triple equals?
There is no triple equals. Just remember the triple equals is to get around automatic conversions, automatic type conversions in JavaScript. So what you have to do is if you want to use equals, you have to actually implement equals yourself. So in here I might say, well, let me actually put this after the toString. So at override, and I need to override equals and implement my own version. And it gives me some suggestions. And in fact, the IntelliJ is smart enough now that it can kind of actually build it for you. And you just basically hit through and hit finish. Okay. So it actually can kind of generate a version of it for you. Now, there's a lot going in here all of a sudden with the version that it generated because, as it turns out, equals is not the easiest method to implement or implement correctly. So there's a few things going on here that have to be there. So let's start with this. So what's the first thing that it does? It says if this is equal to the other object, right? Why might we need to check if this is the other object? What's that doing?
Is that still checking memory location?
It's still checking memory location. Yep. So this is saying if we're comparing ourselves with ourselves, right? So that's the case if you were saying P equals P, right? If I compare myself to myself, that should always come up to true. Does that make sense?
Yeah.
So if you're comparing to yourself, then it should come up true. The next check we have, well, we're saying is the other thing that we're comparing to, if it's null, well, then obviously I can't be the same. Does that follow? So if we compare it with null, then it comes out false. So that would be like if P equals null. So I want that to definitely come out. Well, that can't be the same, and I need to do that early so that it doesn't crash. Because I don't want it to get down here and try to reference the parameters and then crash. Okay. So the next thing we've got, you'll notice here that is checking the class, that the classes are the same. So it's saying if the classes are different, then return false. Do you see that?
Yeah.
So that the reason that that's there and the reason you typically want to include that is you want to say if I've got a subclass of the thing. So I've got a subclass of person. Say I'm comparing a person to a teacher, just go automatically fail because they're different classes. Does that make sense? So that's why that exists there. The next thing you see here is what we call a downcast. So we're taking O, which is the input. You see what type the input is? It's object. Well, if I want to reference the fields of this, I need to cast it and say, well, it's a person. Do you see that? Because I can only compare persons to persons. The next logic that they've kind of automatically filled in here, let's look at what that is. So, and it's actually kind of odd that the name is all the way down here. So let me move that first. Or I'll just leave that at the end. So first they're comparing the age, right? So it's saying age is equal to person.age, right? So this age on the left is my age, right? Is the age of this object. The thing on the right is what? Is the age of the other thing, right? And so I might say this dot age, oftentimes I'll write it that way, this dot age is equal to person dot age. And then they're doing some weird, a little bit of an odd check here. They're saying this double compare method. Let's trim that out a little bit and simplify, because in this case, it's not really worth talking about what that is. The catch is basically that you can't compare. You typically don't compare doubles or floating points directly because you have some rounding error. So things may be very close but not exact. So that pulls some of that out there. So it might look something like that. The age, the height is the exact same, and I might say this dot single is equal to person dot single. And oftentimes, rather than calling this maybe the data type, I might say other. Does that kind of follow for the equals implementation? We have to compare each field one by one. Do you see that?
Yeah.
And then finally we get down to here, and it's doing something a little bit different. So it's saying objects dot equals, right? This name, other name.
Mr. Smith, that order, age, height, is single. Is that alphabetical order, or is that way for a reason?
Typically, the order I put it in is actually the order that I've declared the fields in the class. That's usually the order I go for. It generated it in that order, moving the other one to the end, but usually I would put it in the order of the fields.
Okay, it was alphabetical, right? Or is there some other reason it did it?
No, it wasn't alphabetical. I think it was, well, maybe it was. I don't think it was alphabetical, but maybe it was. I'm going to guess that it just moved this one to the end because it was a reference type and the others are primitives. I'm going to guess it just did the primitives first and then the references last. Anyway.
Okay, I get it, yeah.
So typically that's the way you write it. The catch here, remember I talked about the fact that if you're comparing two reference types, you can oftentimes get null reference exceptions, right? So if one of these people had a name of null, then that would be a problem. So object.equals, what this does is it kind of deals with that null case. It's got some pre-built logic that deals with the null case. Got it?
Yeah.
So we're going to say objects.equals, and that's kind of the way you implement that. The hash code is something that you need to also implement anytime you implement equals. You're also supposed to implement hash code, because this is used by hash maps and has a certain relationship because of that. So the rule about the hash code method is anything that you compare here also needs to be part of the hash. Got it?
Okay. Is there a repository you have of all these things you're doing, so we don't need to type this out or find it one off, like a
I
separate repo you can create?
Yeah, I'll need to upload it somewhere. But yeah, I can give this code. Actually,
Yeah.
probably what I'll do is just take this class. If I take this class out of this file and put it over, yeah, I'll just leave it separate. But I can give you these two classes because that's really all you need.
Okay. Okay. And again, how did you just type
Mm-hmm.
the ampersand, or not the ampersand, the at sign, right?
Yeah,
And that
I
triggered.
started typing at override, and it
You have
kind
to
of
type
gave me
at
a
over.
suggestion about that. But oftentimes, as you kind of see, I usually end up twiddling with these a bit, so you can kind of see the format that usually ends up in. The point is, once you've implemented, typically you have to implement your own equals if you want to be able to compare your own objects. Cool?
Yeah, can't you just use handlebars for that? No, I'm just kidding.
Yeah, you typically have to write your own equals method for your data classes. So that's kind of the start. We obviously need to talk about inheritance and interfaces, but I'm going to push that back to tomorrow, and we'll kind of finish up the discussion there. So I'm going to give you these files that we just wrote, so you can look at them. Open in Explorer. Open this window up here, and there you go.
Right. So for the rest of the class, we just work on the labs.
Yeah. So you can work on the labs. Um, so you should try to finish up that worksheet that's already been assigned today. The next thing that you want to do as soon as you finish up the worksheet, again, I would stress finish the worksheet first, because that'll give you some intro in working with IntelliJ and the IDE. Once you finish those, what you want to go do is the second assignment. You'll see it on Ensign Ranken as Lab 0B. Does everybody saw that?
Yes.
So what you want to then go do is these are on Code Wars, which is a kind of a site that you can do. There's a lot of programming problems, and they're available in a lot of different languages. So you do want to make sure that you pick the right language. When you go in here, you follow my link to the list. You'll find that it will probably have picked another language in here. So for instance, C#. So you'll probably want to make sure that you're in the right language. So make sure you pick Java and go through that. So these are kind of what I put up here is a collection of common sort of interview type problems that are often used for interview questions. So they're good kind of a starting point for basic understanding. And the way these work, obviously, if you haven't created an account, you'll need to create an account. One thing I noted in here, you'll want to make sure when it asks you for what clan you join, you want to join the Ranken Technical College clan. That will let me be able to see your progress and assign you a grade. Otherwise, I won't be able to find you. Does that make sense? Because that's the way I'm going to find you on this website. So if you're looking at, say, the home page on here, Yeah. So if once you get logged in the homepage, you should see a bunch of people here in the Ranken Technical College clan, and that's basically the way I'm going to be able to find your account.
Mr. Smith, I've started it, but like it's like confusing. Tell me whenever I complete them.
It's what?
It's not telling me whenever I complete them. Like I complete them, but it doesn't like update my KYU, I guess.
Yeah. So your rank, you kind of level up. So you have to get a certain amount of experience before you go to the next rank. So the way these kind of work, let me go into one of these so I can kind of explain the UI. So once you get in here, here's the kind of prompt. To start it, you're going to go to your language of choice, say Java, and click train. Here it says train again because I've already completed it. So once you get in to actually solve the problem, this is what you're going to see. So here's the kind of the explanation. On the left is the explanation of the problem. What's here on the right, you see it says solution. That's where you're going to write your answer, write your code. And then what's on the bottom, these are what we call unit tests. So this gives you a way to kind of test it and see if it works. So if we read into the code a little bit, there's a few things going on. But you can read in here that it's going to basically put in 67, and it's going to have 67 is basically what it expects you to output, and given 67, it expects you to output 67 as a string. Does that make sense? So your function takes 67, should output 67 as a string. So let's try this, right? So let's say we want to put some code here. Okay, our objective is to take the value that's input and turn it into a string. Okay, so what should I put here in the body of this function? Maybe let's try return test, right? Let's just see what happens if I do that. If I say let's always return test. Okay, you'll see that there's two buttons down at the bottom. Do you see that on my screen?
Yeah.
Yeah.
So there's this test button and there's the attempt button. Okay. So you see the tooltips says test against the sample tests. Attempt says test against the full test suite. So this test button will only test it against the tests here. Attempt will actually test it against the full test that you need to do to pass it. The difference is that obviously you can define your own tests here. You can't define your own tests here. And this attempt usually takes longer than running tests. Okay, so let's just... Yep.
Do you get, I mean, obviously, do you get unlimited attempts, or is it like you only get one attempt, or you have to wait 10 minutes to redo it?
You get unlimited attempts either way.
Okay.
So let's say we hit test, and it'll spin a little bit and come back with some output, right? So here it says it expected 67, but it was test, right? Because I returned the wrong thing, right? So it gives you some feedback. And in this case, it's just running these three tests here, right? So let's say I just say, well, let's cheat, and we know the first answer is 67, right? So I'm going to say, let's just return 67. Well, what I'm going to see over here, I should see, what does it say now? It's expected 1, 2, 3, but got 67. So which test did it fail on?
The next one down.
The next one down, right? So it's going to try each of these in sequence, and it's going to give us an error if one of them fails. If I do something that isn't valid syntax, it'll tell me that as well. So I say return num. Well, that needs to return a string, not an integer. So it'll give me a compiler error like that. Okay? So once I get to a point where I want to actually try it on the full test suite, so what do I need to maybe put in here to finish this problem? What do I need to actually convert the number to a string? Anybody?
Integer dot toString and then put num.
So integer dot toString, and then
Yes.
put num.
How
Nice.
does not work?
After toString, put in the parentheses. Num. Put num inside the parentheses.
Okay, so let's clarify to the compiler what we actually want it to do. Okay, so we're passing num to toString. Try that. And so you see I've hit test, and if I keep hitting test, it's not actually going to give me credit for finishing this problem. Okay, it's just going to say it's green here. If I want to actually get marked done, I need to go to attempt. Do you see that? So to actually finish this problem, I need to hit attempt. So this bottom button here, it's blue, it says attempt. Do you see that? It's going to change in a minute. So I'm going to click it. It's going to go run it on the larger test suite. It's going to take a little bit longer time. And you see, hey, it's all green. Now, notice that I've passed the full test now. What happened to my button?
Submit.
It changed to a green submit button. So there it says submit your solution and view solutions. So in order to complete the kata, complete the problem, you have to implement it, run attempt once, and pass all the tests. And then finally, you have to hit submit, right? So once you hit submit, that's where it'll actually save your solution and bring you to this screen.
Okay, so the only difference between test and attempt is that the attempt one takes longer. It's a little more thorough. Other than that, it's the same.
Well, what were you going to say, Corey?
No, I was gonna say how does the points work? Do you get points on completing it, or do you how does it?
So you don't get points until you complete it. You get a fixed amount of points based on completing it, and that's it. So you either complete it or you don't. If you don't complete it, you don't get any points. If you complete it, you do get points.
Okay.
The amount of points that it gives you is based on the rating of it. So 8 key KYU is the easiest. It's kind of this black belt rating. So 8 is the easiest, 1 is the hardest. Does that make sense? So,
yeah.
But what I've asked you to do is just to do 20. So you can pick which of the 20 you want to do. I would suggest at least trying some of the harder ones, but you'll notice that I've mostly picked easier ones. The
How many
last
are
one
there?
is 4. Huh?
How many are there?
There should be around 20-ish. Yeah, there's exactly 20. There's exactly 20. I forgot I kind of trimmed down to change the list. So there's exactly 20. You'll just want to do all the ones on this list.
Okay, you only have 4 KU?
4 KU. Yeah, that's a higher rating. When you start, you'll start at 8.
Oh, okay. So less is more.
Yeah, less is more because it's black belt rating. So less is more. So you'll start at 8 and you'll kind of work your way up. I've been playing around on the site for a few years, so every off and on, so I have a few more points.
Cool site then. You had mentioned before this there's a sheet to fill out. Is that the test?
Sheet.
It looks like an exam. Looks like our old clicking tests. Yeah, under inside Ranken.
Yes. Yes.
Yeah, I just want to understand because we got the 20 or so, 20 out of 25 problems that we're working on now for. And then there's the code wars, and then you said a sheet.
Yeah.
It wasn't
so
clear.
there's you see my screen. There's a few assignments for this week. So you've got the perusal, which you've already started the reading on. Let me make sure I pull this up. So for perusal, the dev environment setup, those steps, I need to go back and look at my check sheet, but I had posted one a few like last week sometime. The code with Mosh tutorial, so the discussion on there is that part, um, which you should have gotten most of the credit for the questions I've already asked. So just check your grade on that. So you got the console project, Code Wars, and then the homework. So there's a homework quiz that's a review of kind of all the stuff we've talked about. Some of these questions we haven't talked about yet. We'll talk about them tomorrow. Okay. But, I would definitely stress, well, this is due by Friday. So you may want to get started on it. There's a good number of questions on it, but it's basically a review of the stuff we talked about between Code with Bosch and the quick reference guide.
Okay, so get this done by Friday.
Yeah.
Before class, or like just get it done.
I think that if you go back and look,
it's 11:55 p.m. I think.
Right.
Okay.
So that's what the due date on is. It's
okay.
It's by midnight on Friday.
In Code Wars, you were saying we might run into some time trouble, so maybe that'll be pushed over the weekend. Code Wars.
I can't push that too much. If I change anything on that, I'll change the number of problems that are due.
Yeah.
That's the only thing I'm going to change on that is the number of problems that are due. Because we really do to stay on pace. We need to start on Android next week. So
it's more realistic our schedule compared to last semester.
So. That's what that is.
Wow, so we got a lot. There's a lot going on.
Yep. But a lot of this, I mean, if you've looked at the worksheet, you should have already seen that a lot of those are very simple programs, so it shouldn't take you too long.
Oh, you mean the lab sheet?
Yeah. If you look at the lab
when you say worksheet, that throws me off. The labs.
Yeah, the labs, you should see that they're pretty simple.
Okay.
For those that are interested, our first hands-on test will be on February 8th. Is our first hands-on test.
What's on it? Can you tell us?
So that will be based on it'll be Android, and it'll be based on the first three lessons of Android.
Is Friday going to be? Is tomorrow Friday going to be a lab day as well?
It should be. Thursday. Remember, we're going to talk. Yes, Friday.
I know you want to talk more about what we did today tomorrow. But I didn't know we were not having a hands-on test on Friday.
Yeah, no, Friday is just a lab day.
Okay, gotcha.
Friday is just a lab day. So, yeah, there's no hands-on test this week. So our first hands-on test, I'm pushing it back to the end of Unit 1.
Okay.
I dropped the hands-on test for Unit 0 to kind of save some time.
All right.
Yeah. Now I'm not so worried because I thought all this had to be due before a test on Friday.
Yeah, there's no test. There's no test this week.
Okay.
It's just the lab work and the homework. So.
Okay. How many tests we got? Hands-on tests we got 4.
So you got hands-on test 1, 2, 3, 5, and 6. I believe that's 5 total. 5 total hands-on tests.
So there's not going to be one every week then?
No, there's not one every week. There's one every few weeks.
There's counting. Was there a number missing in there?
Yeah.
Yes, there was number 4. Because I won't do a hands-on test unless on Unit 4.
Oh, okay. Oh, good. That goes right in with spring break.
Yeah, that's right around spring break. So I'll the stuff from Unit 4 will be on the Unit 5 hands-on test.
Yeah, we have to be careful about spring break because last year it didn't go out too well.
So. So your stuff for that unit will be on this hands-on test instead.
So are these hands-on tests just larger, or is it like just more chapter-based, and some chapters don't require hot tests?
It's a mix. Some of the chapters are not big enough to test on, But it's also a case of some things just need a larger test too. It's mixed on that front.
I mean, I didn't know if we were gonna do like a hot test like we did last semester, where it took us like 2 months to do.
Yeah. I may give some of these. I may give you some of these. I think last year I gave all of these as a take home test. Last year or two, I've given these as a take home test.
Like over the weekend, you mean?
As in give you it early. So you may have.
Oh.
I will probably give you hands-on test 1, etc. I will probably give you some of those tests earlier before the day that they say they're due. If that makes sense.
Yeah.
So that's the due date on it. That's not necessarily the date that you're gonna get it on. So you probably get it on a week or two before. Is what I've usually done. Cool.
All right.
Okay. We'll let you get back to the labs, ask me questions as you should, and again, we'll kind of continue with the object-oriented review tomorrow. Are there any questions so far on the things that we've talked about today, kind of covered? Obviously, we haven't touched interfaces.
No, for me, I'm just trying to like get my head back into C# and all of that, the whole formatting stuff.
Okay.
All right, cool. So we'll get our devices tomorrow.
Yes, you'll get your devices tomorrow. I've got them all set up. I got all the hardware